All right, so this is the key to worksheet number 2 on equations. So we have 3 equations here, so let's look at the first one. Notice that in number 1, this is a rational equation. So that's a rational equation. I'm going to go ahead and write that here. So that's a rational equation. And so what makes that a rational equation is basically, if you look at your terms, you see a fraction, right? So that's a fraction, that's a fraction, that's a fraction, and in particular, the denominators contain variables. You can have variables in the numerator, you can also have variables in the denominator, but what makes this rational is the fact that you'll see variables in the denominator. All right, so that's rational. Now, the way you want to solve this rational equation, just like you did with another worksheet, remember worksheet number 1, where you had number 2, this equation with fractions, although this was linear, it is also rational because you have fractions here. All right, but notice that this is not linear because the variables are in the denominator. So if there are variables in the denominator, it's automatically not a linear equation. So we just call this rational. But remember what we did in number 2. To do number 2, what we did was we found the LCD, and then we multiplied both sides by the LCD, and we had to do all this work. Remember that? All that work? Okay. Same thing here. You're going to do the same thing. So we're going to find the LCD. The problem here is that your LCD, your denominators are variable expressions. Whereas in this one, your denominators were integers. So it's pretty easy, it is very easy to find the least common denominator when integers are involved. When you have variable expressions, you just got to be a little bit more careful how you're going to find the least common denominator, and you had to do that. So notice I did say indicate to me the least common denominator, and then indicate to me the restrictions. So you have to say LCD equals. All right, now to find the least common denominator, you're going to factor all of your variable expressions that's in the denominators. So notice this is a linear factor, so I cannot factor that any further. This is linear, I cannot factor that any further. This is quadratic, and you learned about factoring quadratic expressions. Students sometimes have trouble factoring quadratic expressions, but when we're dealing with equations, it's kind of there's kind of a way you can cheat, so to speak. So sometimes what happens, and many times, the way you're going to factor this is going to involve the factors from the other denominators. So you see these two factors here? So you may say, well, x squared plus x minus 6, I think I can factor this as x plus 3 times x minus 2. All right, and so you would go ahead and you would kind of check this, right? So you'd say, all right, let's go ahead and check this. X plus 3 times x minus 2. And so to multiply two binomials, I'm going to use the fall method. Remember the fall method. So first, x times x is x squared. O means outer. So your outer. X times a negative 2 is a negative 2x. I means inner, so you inner terms. 3 times x is 3x. And then L right here means the last terms of each binomial. Positive 3 times a negative 2 is a negative 6. Combining like terms, x squared, a negative 2x and a positive 3x is a positive 1x. So we just say x minus 6, and notice this right here is this. All right. So first thing you do when you have variable expressions, you want to factor the denominators. All right, so once you factor the denominators, you can now find the LCD. Your least common denominator must include every factor you see. So my first factor I see is x plus 3. So I have to use it. My next factor I see is x minus 2. I have to use it. And it's a product, so don't put this a comma. There's always a few students that put commas here, which implies they don't understand what it means by the least common denominator. So the least common denominator is a product of, of, of factors in your denominators. And you want to make it the least, not a common denominator, the least. So the smallest possible. Then we go to the next factor, x plus 3, but it's already here. So don't include it again, because then it would no, if you include it again, it would no longer be a least. It would just be a common denominator, which would make things more difficult for you. The next factor you see is x minus 2. I already have it. So there's your least common denominator. So your least common denominator is the product of these two factors. Then you want to find the restrictions. So I had to see the restrictions. So in other words, if you do all this work and you come out to be, let's say, x equal 2, then x equal 2 cannot work because when you substitute 2 here, 2 minus 2 is 0, and you cannot have 0 in the denominator. 5 divided by 0, if you think about it, look, 5 divided by 0 equals, that's undefined. You get divide by 0 error, which means you cannot divide by 0. So then if that's the case, x equal 2, that would be one of your restrictions, then you couldn't use it. That would not be a solution. All right, now to find the solution is basically asking yourself this. You're asking, what makes this denominator 0? So you're asking, where is x plus 3 equal to 0? Well, x plus 3 equals 0 when x equals negative 3. So there's one of your restrictions. So x cannot equal negative 3. Because if x equals negative 3, then negative 3 plus 3 is 0, and you get 6 divided by 0, which is undefined. Then we go to the next denominator, x minus 2. Where is x minus 2 equal to 0? Well, x minus 2 equals 0 when x equals 2. So 2 minus 2 is 0. 5 divided by 0 is undefined. We just talked about that. So there's your other restriction. So x cannot equal 2. Then we go to the next factor, x plus 3. But I already have it. The restriction, this, is the same as this one. It's negative 3. We go to the next factor, x minus 2. Well, that's the same as this. So those two will have this. What makes this 0 will also make this 0. So I already have it. So there's only two restrictions. All right. So you had to find the LCD and you had to tell me the restrictions. Okay, now, what we're going to do next is the same way we did the previous problem. We're now going to multiply both sides by the least common denominator to clear the fractions. So remember the previous one, I had denominators, I had fractions, so when I clear them, notice I no longer had fractions, and it make things a lot easier for me. Okay, so let's go ahead. Notice on the left-hand side there are two fractions, so I'm going to put that in brackets. So I have 6 divided by x plus 3 minus 5 divided by x minus 2 equal, and then negative 20 divided by, and always use the factored part here. So we're going to say x plus 3 times x minus 2. All right, now I'm going to multiply both sides by the least common denominator. So I'm going to say x plus 3, x minus 2. What I do to one side, I have to do to the other. So times x plus 3, x minus 2. Now at that point, just like we did in the previous problem, right here, I'm now going to go ahead and distribute. So I'm going to multiply every fraction by the least common denominator. So that's how I went from here to here. Same thing here, except this time you're going to have variables. So you're going to say this LCD times the first fraction, and then minus this LCD times the second fraction. So we can use the distributive property. So I get x plus 3, x minus 2, times 6 divided by x plus 3, minus, and then x plus 3 times x minus 2 times 5 divided by x minus 2 equal, and then negative 20 divided by x plus 3, x minus 2 times, all I'm doing is just rewriting the right-hand side over. So x plus 3 times x minus 2. Now, just like we did in the previous problem, we're going to now reduce. Okay, so we're going to reduce. So remember, the whole point of multiplying by the LCD is to get these denominators to be 1s, to be factors of 1. And now if I'm doing this correctly, this right here should no longer be x plus 3. It should now be just a 1, and it is. Because look, x plus 3 divided by x plus 3 is 1. So put 1's in their place. Over here, x minus 2, x minus 2. So x minus 2 divided by x minus 2 is 1. All of this you see here. So all that is 1. All right. And then now we're going to rewrite this. We have 1. Now remember, multiplication is commutative. So the order in which you multiply does not matter. So notice I have 1 times x minus 2 times 6. So the way you want to do this is you want to say 1 times 6 is 6, and then 6 times x minus 2. So that's how you're going to rewrite this one. Subtract. Don't forget that subtraction. And then you're going to say x plus 3 times 1 times 5. And the way you want to do this is you want to say 1 times 5 is 5 first, and then put 5 in front of x plus 3. So this right here means this. Equal, and then all you're left with here is just negative 20. Negative 20 divided by 1 is negative 20, and the negative 20 times positive 1 is still negative 20. So I want you to notice that I went from this rational equation to a linear equation. All right, and now we're going to solve this linear equation. And so we're going to do this by using distributive property. So I'm going to distribute 6 here, and then I'm going to distribute negative 5 here. So 6 times x is 6x. 6 times negative 2 is a negative 12. Negative 5 times x is a negative 5x. And then negative 5 times 3 is a negative 15, equal negative 20. Combining like terms, 6x and a negative 5x is positive x. Again, if you have to, say 6 minus 5, say 6 minus 5 equal, and you just get 1. All right, but don't put a 1 there. Just makes things look not well. Just put x. So x means the same thing as 1x. So just put x. That's the way we write it mathematically. Now, combining the constants, a negative 12 and a negative 15, again, if you can't remember how to do the sign numbers, you just do that here. So just make sure you're using your calculator whenever possible. So negative, you're going to press the negative symbol right here, negative 12 plus, and then negative 15 equals negative 27. So this becomes x minus 27 equal a negative 20. And then to get x by itself, right now I'm subtracting 27. The opposite is to add 27. So if I add 27 on the left, I have to add 27 on the right. And now combining like terms, a negative 27 plus 27 is 0. So this becomes x equal, and the negative 20 plus 27 is a positive 7. Now you remember you have to check your solution. You had variables in the denominator, so you have to look at your restriction. So is x equals 7 one of my restrictions? The answer is no. So that means that this, as long as it did the word correct, then this would be a solution. All right, and so that was number 1. Okay, let's look at number 2. Number 2, we have this equation, 3x minus 1 squared equals a negative 16. Now, this is quadratic. This is quadratic, and it's quadratic because if you think about it, I have 3x minus 1 squared, right? Well, 3x minus 1 squared means 3x minus 1 times itself. And if I were to multiply this out, notice what I have here. 3x times 3x is 9x squared. So that makes it quadratic, the fact that the largest exponent is 2. All right? Now, the way you want to do this, and if you go back to, if I can find it real quick. So if you go back to your worksheet, it says you must use the square root property. Okay, so always follow directions. So the square root property says this. So if you have some expression squared equals a number, so kind of like a squared equal a number, then to get a by itself, right now I'm squaring. The opposite of squaring is to take the square roots of both sides. So you can say square root, square root. But remember, you have to add that plus or minus. And so now the square and the square root undo each other. So you're left with the radicand here, which is a equal plus or minus the square root of the number. All right, kind of makes sense because if you look at x squared equal 9, there are two numbers whose when squared is a positive 9. So that will be x equal 3, x equal negative 3. Both of those when squared is going to be a positive 9. So when you do the square root property for that one, you're going to say, just like this, plus or minus. So you got to do that plus or minus. And so therefore, the square and the square root undo each other. So you're left with x equal, and then plus or minus, and the square root of 9 is 3. So you can do the same thing with this one. So I'm going to rewrite this over. So the way you're going to do this is now you're going to take the square root of both sides, just like this. Notice that negative 16 is under the square root. But we need to put that plus or minus, so if we get that plus or minus. Now the square and the square root undo each other, so you're left with 3x minus 1, the expression 3x minus 1 equal plus or minus. Now you have to think about this. So we all know that the square root is 16. So what number times itself is 16? So that's what the square root means here. What number times itself is 16? The answer is 4. So the square root of 16 is 4. You can even check it here. Square root, let's get the square root symbol. Square root 16 equal 4. Okay? Now, if you had the square root of a negative 16, so you may say, well, I'm going to put that in the calculator, see what happens. Square root, negative 16 equal, you get a domain error. All right, you may say, well, then I don't have a solution. But remember, you learned about, in your lessons, you learned about imaginary numbers. You learned about imaginary numbers. And so you learned by definition that if you have the square root of a negative 1, that is defined to be the imaginary unit I. All right, so you learned about imaginary numbers, you learned about complex numbers. So what that means then is, see the square root of negative 16? So I can write this as the square root of a negative 1 times the square root of 16. So negative 1 times 16 is negative 16. And then the square root of a negative 1 we now know is I. And then the square root of 16 we know is 4, but we tend to put the I in the back. So don't say I times 4, just say that's equal to 4I. All right? And so that's what this is right here. So the square root of a negative 16 is 4I. All right, so my solutions are going to be imaginary numbers. They're not real numbers. They're imaginary numbers. And so now the fact that I have an I in my answer, an imaginary number in my answer, here's the way I would do this. I would, first of all, remember trying to solve for x now. I would add 1 to both sides, just like this. Now be careful. So combining like terms, negative 1 and 1 is 0, so you get 3x equal. Now, some students make the mistake and say 4 plus 1 is 5. That's not what that is. Okay? So this means 1 plus or minus 4i. That's what that means. That's not 5i. Because those are not like terms. See, you don't see an I here. That's just 1. You see an I here, but not here. So you have to be careful how you write these. And then finally, to get x by itself, right now I'm multiplying x by 3. The opposite is to divide by 3. And so when I do that, 3 divided by 3 is 1. 1 times x is x. So you get x equal 1 plus or minus 4i divided by 3. So there's your solution. Notice there are 2 of them because I can write this, think about it, I can write this as 2 separate solutions. 1 plus 4i divided by 3, and the other solution would be 1 minus 4i divided by 3. All right, so either one of those would have been fine. All right, so that was number 2. So don't forget about imaginary numbers. You learned about that. Okay, and then number 3, I'm going to go ahead and put number 3 here so I can put it all on one page without being too messy. Now, number 3, we had this this quadratic equation, 2x squared plus 4x equals 3. And so the directions for that one said this. Solve by using the quadratic formula. Okay? All right. So remember, the quadratic formula is this. So when you have a quadratic equation, let me take all this out of the way. So when you have a quadratic equation, ax squared plus bx plus c equals 0. Notice you have to have 0 here, so that's standard form, or standard notation, standard form. So you want 0 on the other side. Then the solutions to this equation can be found by using the quadratic formula. So the quadratic formula is this. Quadratic formula. All right, it will be x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of that. So you have to say all of that being divided by, and then 2a. So that's quadratic formula. So to solve this quadratic equation using the quadratic formula, you first of all have to rewrite this in standard form. So you want 0 to be here. So you got to bring the 3 over. So when I do that, I get 2x squared plus 4x minus 3 equals 0. Now, before I substitute values into the quadratic formula, let's first of all determine what a, b, and c are. So a, okay, remember a is going to be the coefficient of x squared. So that's 2. B is the coefficient of x. That's a positive 4. Got to keep the sign. So this was subtract 4x, then b would be a negative 4. In this case, it's a positive 4. And c is your constant, a negative 3. Don't say 3. That's a negative 3. Subtract 3, negative 3. So there's a, b, and c. So now I'm going to substitute these values into the formula. So remember the formula, the opposite of b, plus or minus the square root of b squared minus 4ac over 2a. And notice the similarities here. See this, the plus or minus right here when dealing with a quadratic equation. You have that plus or minus. You have it here, plus or minus. Okay, so x equals the opposite of b. So b is 4. The opposite of 4 is a negative 4. Plus or minus the square root of b. Always put b in parentheses. So b is 4. I'm going to square that. Then I'm going to subtract 4. So all I'm doing is this, the discriminant, the radicand in this case, the discriminant. So I'm going to say minus 4 times a, which is 2, times c, which is negative 3. All of that. So you got to make sure you when you do that division symbol right here, you go from negative 4 all the way to the end of your radical expression. All of that is being divided by 2 times a, and a is 2. All right, now equal. Let's go ahead and simplify the radicand. Remember, when you're dealing with a quadratic formula, this is also called the discriminant. So I have the opposite of 4 plus or minus the square root of 4 squared means 4 times 4, which is 16. All right, now the rest of this, you use your calculator if you have to. So you're saying negative 4 times 2 times a negative 3. Okay? And so when I do that, I get a positive 24. So you can say 16 plus 24. All divided by, and 2 times 2 is 4. Equal. All right, 16 plus 24 is 40. So you can say negative 4 plus or minus the square root of 40 divided by 4. Okay, now, one of the things you learned was to simplify radicals. So you must simplify the square root of 40 if possible. So let's think about 40. I can simplify square roots. By looking at perfect squares. So if you stop here, you would not get all your points. You get most of it, but not all, because I wanted you to simplify the solution as much as possible. So the square root of 40. So the square root of 40, the largest perfect square that goes into 40 is 4. So this becomes, remember, using perfect squares. I'm using perfect squares. So remember, your perfect squares, the smallest one's 1, then the next one is 4, then the next one is 9, next is 16, 25, and so on. So these are all perfect squares, which means that if I take the square root of 1, I get a whole number. If I take the square root of 4, I get a whole number. If I take the square root of 9, which is 3, I get a whole number. If I take the square root of 16, which is 4, I get a whole number. Now notice notice the pattern here. 1, 2, 3, 4, 5, 6. So if I want to get my perfect squares, I just take 1 and I square it. Get 1. The next one will be 4. To get 4, I'd say 2 and I square it. I get 4. Next one is 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, and so on. So those are your perfect squares. So to simplify square roots, you want to see besides 1, because 1 goes in every number, 1 is a factor of every number. You want to see is there a perfect square that will go into the radicand, in this case 40. And you always want to use the largest. And in fact, other than 1, the next one is 4. That's the only other one. So then we're going to rewrite this as the square root of 4 times the square root of 10. And then we know that the square root of 4 is 2, so this becomes 2 square root of 10. You cannot simplify the square root of 10 because 10, besides 1, there is no other perfect square that goes into 10 evenly. And so that's how you're going to rewrite the square root of 40. It's going to say 2 square root of 10. So what I needed to see was this now. I need to see you say negative 4 plus or minus 2 square root of 10 divided by 4. All right. And then the next thing you want to do is see if you can simplify these values right here. So negative 4, 2, and 4, they all have 2 in common. And so you can write this a little bit better. So you could say negative 4 divided by 2 is a negative 2, plus or minus. 2 divided by 2 is 1, right? So that just becomes square root of 10. Divided by, and then 4 divided by 2 is 2. And so there's how you would write this. And there are multiple ways you can write this. You could write them separately. So instead of saying negative 2 plus or minus, you could say negative 2 plus the square root of 10 divided by 2, comma, and then negative 2 minus the square root of 10 divided by 2. So write them separately, do your two solutions. Some students will go ahead and even write these as fractions. So in other words, let me go ahead and write this here. So in other words, let's say we had negative 2 plus or minus the square root of 10 divided by 2. So in other words, what they would do is they would say, well, I'm going to take negative 2 divided by the denominator, plus or minus, and then take square root of 10 divided by the denominator. And then negative 2 divided by 2 is a negative 1, plus or minus. Now be careful. See, this is not a 10. That's a square root of 10. So don't say it's incorrect now, because there's always 1 or 2 students that will do that. They want to say this. They want to say 10 divided by 2 is 5 and say that's the same thing as saying square root of 5. It is not. You can even check it. Look, the square root of 10 divided by 2 is approximately equal to 1.58. If I take this, so let me do that here. 1.58, approximately equal to. The square root of 5 is approximately equal to 2.24. See, those are not the same. All right, so be careful. So that was just a 10, then yes, 10 divided by 2 is 5. But that's not 10, that's the square root of 10. That's an irrational number. You're trying to divide an irrational number by a rational number. You cannot do that. All right. So then what they're going to do now is just going to leave it like this. Square root of 10 divided by 2, and that's it. All right. So I'm just going to say, or you could say negative 1 plus or minus the square root of 10 divided by 2. So multiple ways of writing this as long as they're mathematically correct. All right, so that is pretty long, right? A lot of little things you have to keep track of, but it's doable. It's not that difficult. Again, always remember you follow directions. And so that was the key to worksheet number 2.